Welcome everyone. In this video we are going to derive a formula for finding the potential energy of a capacitor. Actually we will derive three different formulas, but they will be very similar formulas. We will be able to go between each of them, okay? But there will be three of them. So let's get started. The way I want to start is by considering the differential of the potential energy, du. This is going to be equal to the differential of Q, the charge, times V, the voltage. Not the voltage, actually the electric potential. Okay, this is how we define electric potential. Electric potential is going to be defined as U divided by Q. Alright, this is by definition correct. So we got this. And now what I can do is I can take the integral of both sides. Why not do that? Let's do that. So I take the integral on both sides and the let's see. So the left integral will start from 0 and go up to u. And on the right we need to make a decision. And the way that I am going to make the decision is considering d. Where should I put it? And in fact, I will put it, let me write it here. I will put it like this. It will be in front of the Q. Because why did not I put dV? Well, the idea is like this. If I have dq, I can think of this as, I have the capacitor system. I can think of it as having a very small and infinitesimal charge dq and moving it through the capacitor. Okay, and when I do that, I ask the question, how much energy will it gain? And that energy will be the potential energy of the capacitor. That's why I put the D in front of the Q, because it makes sense that we have a infinitesimal charge. Alright, so we got this, and then I will have the boundary from 0 up to Q. And Q here will be the charge of the capacitor. So this is plus Q perhaps, and this is minus Q. Negative Q, I mean. So with this in mind, let's continue. So from on the left, it is fairly simple. We will simply have U, which is what we are looking for, don't forget. And on the right, we now have the integral from 0 to Q of V dQ. Alright. And how does this help us? Well. We know a formula for V for the case of a capacitor. And that formula comes from the famous Q is equal to CV. And if you don't know this formula, you can access its derivation from the cards right now, also from the descriptions part. Now, using this formula, which we already proved in a previous video, we can solve for V. V is going to be Q divided by C. Cool. So let's substitute that. We have from 0 to Q, instead of the electric potential, I am writing Q divided by C, and C here is the capacitance of our capacitor. Then we have dQ. And now we are equipped to take this integral. What is it going to be? It is going to be, we increase the power of Q by 1, we have Q squared, and we divide by the new power, it is going to be 2. We have C, because C is a constant. And our boundaries is Q, 0. So, if we plug in the boundaries, we simply get Q squared divided by 2C. And this is great. But I want to go a step further and give you two more formulas. Now, for the new formula, I will give it independent of the Q. Even if you don't know the charge of the capacitor, you will still be able to find the electric potential. And how does it work? Well, I simply substitute for Q. For the Q here, I will substitute this. So let me do that. And when I do that, I will have C squared, V squared divided by 2C. And let me continue here. That is going to be C's cancel. We have 1 over 2 CV squared. And this is the second formula. This was the first one. And now we have a second one. And I like the second one more because it is like the kinetic energy formula, so it is easy to keep in mind. And also this is in like the kinetic energy formula if you write it like P squared divided by 2m. Okay? But the second one is more like the general kinetic formula. So we have this, but I can do one more thing. I can make this formula independent of C. And how can I do it? By substituting for C. So let's do that. Let's use, let's use this result. So we have 1 over 2. Instead of C, I am going to substitute using this equation. What is it going to be? It is going to be Q divided by V times we have V squared. And this is, if we see that V's simplify to leave us with 1 over 2 QV. And this is the third formula. As you can see, all these formulas, the three of them, are equivalent. You can use whichever you want, and it will be easier to use one of them in different problems. But as I said, they are equivalent. We just made substitution to arrive at them. Anyways, I hope this video was helpful. If you have any questions, please add them in the comment section. I hope to see you in another video. Until then, take care.